Greetings, I am Thomas Bird, and I'm going to tell you how a jet engine works. For starters, in order to fully explain how a jet engine works, I have to explain to you how a rocket works. For now, ignore the diagram that's on the bottom, that sword-shaped looking thing. It will be used later. Basically, you have a tank of oxygen, and you have a tank of fuel. They have tubes that lead to the combustion chamber, and when you spark it, this produces a reaction that generates heat and creates pressure. High pressure goes to low pressure, so the combustion goes out the back, and Newton's third law of motion states that for every action there is an equal and opposite reaction. And so pushing the thrust out this side, it pushes the ship in this direction. Now we pull out the other diagram, which talks about two engines in one. The turbofan and the turbojet. Basically, this is a rocket engine that gets its oxygen from air rather than another tank. The blue represents the turbines, which are basically similar to your fan, but different. Anyhow, the combustion occurs here. As represented by the orange, it attempts to go up both sides. However, because, as you can see, this side has several more turbines than the other side, the combustion goes out this end, pushing the aircraft that way. It creates forward thrust and allows air to move across wings, which are not drawn out here. This creates lift, which allows the aircraft to fly. Now, for a turbofan, you see here this is an extra large turbine. That's the fan. It pushes air above and below the primary jet engine and increases the pressure of the air that goes to the wings. This allows the aircraft to fly at higher altitudes than most propeller-driven airplanes. On the other hand, you see here an additional combustion. This is an afterburner. An afterburner is used in most military aircraft, such as the Raptor or the Tomcat. And while it sacrifices fuel economy, it enables increased speeds, upwards of Mach 2. That put into car terms, that's over 1,000 miles an hour. Pretty fast. Finally, we return to the other diagram, the one that I told you to ignore for then, at that time. Now we get to see what it is. The ramjet. Basically, this jet engine, while similar to the rocket, is also somewhat different. Basically, you compress the air in front using coolant, liquid coolant, and this allows the air to go to the combustion. The combustion pushes the air back out the other end. It enables the aircraft to travel at much higher speeds than is possible with the turbojet or turbofan. And in fact, it allows aircraft such as the SR-71, the Blackbird, to go at speeds upwards of Mach 4. No ground aircraft can possibly go at this speed, but it's about 2,000 miles an hour. Unfortunately, as the Blackbird is classified, I was unable to obtain an exact figure on its top speed, but suffice it to say, blink and you miss it. The air travels through the coolant, and then this is the tricky part, because the air has to be rammed by the cone into the combustion. I cannot emphasize how inefficient the ramjet is at subsonic speeds. It is designed for supersonic, and with subsonic speeds, you need turbines in order to properly compress the air into oxygen form, and so that the combustion can combust. This has been a rather enjoyable presentation for me to give out. I hope you enjoyed this presentation, and I hope you have a good day.